Hello, welcome back to the same definition we've been working on for a little bit. This is this Aqua Tower-esque skyscraper, really more of just a contoured tiered skyscraper. Um, what I am going to be showing you is a really quick video. We spent all this time making this relationship between height and our original shape, and then arraying a certain amount of planes to cut it in order to get these shapes. So this is really good practice to learn. You may need to use something like this somewhere else, and making sure that one part of your definition relates to another part of your definition prevents things from breaking most of the time. At least it can make them more robust. But I would be lying if I told you this is the easiest way to do this. Rhino actually, or Grasshopper actually knows that, as architects, we like contours. If you were kind of exploring or felt a little cheeky, you may have just typed in the word contour. You'll notice that there's a couple of these, but generally this is the contour tool I use, where it's basically very simple. This tool does a lot of what we're doing, essentially making this array of planes and then intersecting them. It will do it automatically. It all puts it together. Also, there's some things that we're putting in here, like unit Z. This is basically telling us that we want our things in this array to copy upwards, by a certain distance, in our case 10. Well, actually, in our case, by 10 as the height. We can do this pretty simply with the contour tool. We can take our original shape, so we're going to take this thing. We're going to plug it in up here. It is already in a direction, so it just embeds that as 0, 0, 1. It's assuming you want to go vertically with it. You can change this if you have a vector you want to use. Be aware that the symbol on the parameter here is an arrow, so it's a vector. So 0, 0, 1 means it's not moving left and right, which is going to be X, or forward or backwards, which is Y. Those are 0 and 0. But it will be moving upwards, which is 1. If we wanted it to contour in a diagonal, we would have to start changing which direction this arrow is. And we can make a vector in a variety of ways, but that's not the focus here. We generally do want to go upwards. So we have our shape, we have our base point, so we're going to be starting at the bottom. In our case, this is 0, 0, 0. You could use some sort of bounding box to figure out what the lowest point is and use that if you wanted to. But in this case, 0, 0, 0 works. And then since we're going up, it won't go anywhere below it. And then distance. So this is going to be essentially what we did for this. So if we take this number and just put it in here, we'll get the same thing that we were getting out of here. So if I select both of these, you'll notice that they're basically the same. One of them has one more. This definition we made before has more control in that you can declare a floor or a ceiling, but the contour tool is much faster. You'll also notice that as this changes, it does essentially hit some of the floor and ceiling conditions, and that it won't be able to create more floors than there are heights for. From here, we can take these resulting contours. So in our case, and we'll pull out a panel to look at it, these things are going to be in closed planar curves because they're cutting a closed surface that are arranged into their own lists. This is, well, let me actually pull the right thing into there. The same thing as these polyline curves. At least in our circumstance. There's some things that these intersections here with Brett Plane do that are different from the contours. That's a more technical, like whether or not like you can approximate the math with this thing, whether you can get a true answer curve out of this thing. But anytime you use this tool, it will basically make a planar curve, while this rep plane will try to make planar curves, but they may be disconnected, so they may not be closed. So anyway, this is, if you had multiple geometry in here that was defined on the shape, like you had a hole or something, then you might get two curves inside of one of these lists instead. But it functions basically the same. So this is a faster way to do it. This is good to know because it starts setting up a relationship, and you will use math like this all the time. But if you do this every single time, you will probably find it very crazy and boring. This is a way to just be faster that I figured you guys would appreciate. Anyway, thank you and see you next time.